The training goal: to weld 3T aluminum structure completely based on the provided drawing. Task: to make aluminum structures using 3mm aluminum material. The objective is to weld aluminum structure completely according to the provided drawing. Goals: to strengthen complete welding skills for aluminum structure. To make sound welds without any defects such as porosity, burn-through, oxidation, etc. To interpret drawings accurately, including the front view, top view, side view, etc. Materials: for the aluminum structure, uses a 3mm plate, height 250, length 200, and width 200. Welding process is GTAW aluminum. Welding rod is 4043 with 2.4mm. Shielding gas is argon 99.9%. Main focus of the task: make sure not to damage the base materials. Clean up the aluminum rod with acetone if there are any contaminants. For aluminum welding, a ceramic nozzle, gas lens, and collet chuck are required. Grind off the end of the electrode with 60-degree angle, not to make the end point too sharp. Prepare water in the basket bigger than the aluminum structure and use it for cooling down the base material heated during welding. Make sure to weld the base material without any misalignment. The aluminum oxide layers must be removed prior to welding with a stainless steel wire brush. The aluminum structure should have a 7mm bead width. Make a guide line offsetting 3.5mm away from the center of the weld line. Start weld for fillet joint after making a guide line accordance with the required fillet size. While welding, pay attention to prevent any defects such as porosity, burn-through, oxidation, etc. Please check the preparations and tools for this training. Precautions: mind not to damage the base materials because aluminum is softer than other mild steels. Use a pure tungsten electrode with a round shape at the end of itself, or the one without sharpening for aluminum welding. Autogenous welding is used rather than welding with a filler metal for aluminum welding. Keep the tungsten electrode away from the aluminum. When it contacts the aluminum, it will get blackish oxidation. Aluminum may be fixed with hands instead of using the fixtures depending on the welder's skill. Therefore, it's required to align the right angle with a square gauge after tack welding. Since aluminum has melting point of 660 degrees Celsius and higher thermal conductivity, the heat from welding may melt the base material. Therefore, proper heat input control is critical. Aluminum may have oxide layers when exposed to the atmosphere at its own characteristic. The oxide layers melt at 2000 Celsius. If it's not removed prior to welding, aluminum material will not be welded properly and accurately. Therefore, remove aluminum oxide layers completely just before starting welding. Preheat the base materials by starting an arc, and when the molten puddle is formed, feed the filler metal. At this time, continue welding by feeding and pausing the filler metal repeatedly in front of the arc instead of feeding continuously. A welder should focus on checking the molten puddle because the weld profile relies on both the filler metal feeding speed and the travel speed. If the welding speed is too slow, melt-through may occur. This might lead to making the hole on the base materials. As more heat is concentrated toward the end point, the welder must turn the arc on and off from 5 to 10 millimeters before the end and finish it with quick spot weld. Aluminum welding is carried out with a single pass, without fill and cap pass. Therefore, the back beads should also be formed with a single pass. Please check the tasks to perform. Preparation of base material weld joints. Cross-check the provided materials with the provided drawing. Count the material quantity, measure the size of the materials, and cross-check them with the drawing. Remove burrs on the edge of the material with a fine file. Aluminum is much softer than other mild steel. Use a more fine file when removing the burrs to avoid making damage on the materials. Request a replacement of the materials if you find the wrong size of the materials or incorrectly machined part before starting welding. After starting welding, material replacement is not possible. Check the material quantity and size carefully by cross-checking with the drawing. Mark which part of the material's location corresponds to the structure against the drawing. Mark the location of the materials on the materials according to the drawing directly with a paint marker to avoid confusing the front and back panels of the plates. Without this pre-prep, it will take longer because it's required to fit the structure and the parts at each step. Knowing the locations of the structure in advance, it helps the work a little more easily. Tack welding for base material. Process the electrode to be used for welding. For aluminum welding, a pure tungsten electrode without thorium is used. Pure tungsten electrode shows a stable arc when AC has been applied and mainly used for aluminum welding. A pointed end electrode is required for DCEN, but the hemispherical tip electrode is required for DCEP or AC. For AC aluminum welding, use a hemispherical tip electrode or the one without sharpening the top. Change the current from DC to AC. Set welding current at about 100 ampere. Start tack welding from the side view according to the drawing. While tack welding, maintaining an alignment is the most critical. Check the alignment with a steel ruler and make tacks at both ends. Start an arc at the butt joint and make tack welds with autogenous welding technique by melting base material with the arc heat without filler metal. Do not let the electrode touch the materials. After tack welding, check if the level of the base material is even. Check repeatedly if there is any distortion with a steel ruler. Tack welding is classified into the butt joint, corner joint, and fillet joint tack welding. Make 2 tack welds for the butt joint, one in the center and the other one at the end. Check if there are any gaps. It is important to make an alignment and keep no gap to avoid a burn-through. Weld tacks at the tip of the plates where the plates are facing each other. Check the horizontal level when tack welding finish. The more plates tack welded together, the higher the chances of plates twist. Check if every plate maintains an even level with a steel ruler. If there are excessive tacks, the tacks should be ground off with a file. Make sure not to make any damages to the base material. File the excessive parts carefully. Tack welding from a side view, front view, and top view in order. Corner joint tack welding. For corner joint, tack weld precisely to avoid the gap between the plates. Making a right angle at the corner joint for aluminum welding is not easy. Therefore, tack weld holding the plates with hands and then align the right angle with a square gauge. The arc length of the tungsten electrode is about 2 to 3 millimeters. Prevent touching tungsten electrode to the base material, since base material will get a blackish oxidation. Whenever tack welding finishes, check the corner angle with a square gauge. If it's not a right angle, correct the angle by bending or flattening material with hands. The welder is welding tacks by holding material without any special fixture at the moment. Fixtures like G-clamp could be used, but pay extra care because aluminum is soft material so that it gets easily deformed. Check the drawing frequently while tack welding and fit up the structure according to the drawing. After fitting them up, check the right angle of the corner with a square gauge. Tack weld for fillet joint. For fillet joint, unlike with other joints, weld with a filler metal. Preheat a bottom plate, and when the bottom plate is melting, progress torch from bottom to top, then weld tack. When preheat from the corner, melt-through may occur. Therefore, preheat the bottom plate first, then welding from the bottom to top. Since aluminum has melting point of 660 degrees Celsius and higher thermal conductivity, the heat from welding could melt the base material. Therefore, proper heat input control is critical. Aluminum welding. Prior to welding, remove aluminum oxide layers with a stainless steel brush. For special welding like aluminum material, cleaning is the most critical step. Aluminum gets oxide layers when exposed to air as its own character. This aluminum oxide layers is melting at 2000 degrees. If it does not removed prior to welding, aluminum material will not be welded properly and accurately. Remove aluminum oxide layers completely just before starting welding. After removing oxide layers, mark the guide line with a marking needle considering the bead width. Mark the guide line for butt joint and fillet joint, except corner joint, since for corner joint, edge of material will be a guide line for welding. Allowable fillet size for aluminum is 4 to 6 millimeters. Weld joint for aluminum structure have zero groove angle. The weld joint is considered as eye-butt joint. Preheat the material with arc heat at the start point and feed the filler metal when molten puddle formed. Continue welding by feeding and pausing the filler metal repeatedly in front of the arc instead of feeding continuously. Move torch only toward the traveling direction with steady hands. A welder should focus on checking the molten puddle because the weld profile relies on both the filler metal feeding speed and the travel speed. Keep in mind that travel speed should not be too slow. When the travel speed is too slow, there is a high chance of burn-through. From 5 to 10 millimeters ahead of the end point, finish with quick spot weld by switching on/off the arc as the heat will be accumulated at the end. Inclined vertical butt joint welding. Maintain 6 to 7 millimeters of the electrode stick out from the torch nozzle. Keep the electrode work angle at 90 degrees and travel angle at 80 to 90 degrees, and weld vertically from bottom to top. Preheat the material with the heat of arc at the start point and feed filler metal when the molten puddle has formed. At this time, continue welding by feeding and pausing the welding rod repeatedly in front of the arc instead of feeding continuously. Filler metal feeding speed relies on the filler metal melting speed. When the filler metal melts quickly, feed it quickly. When it melts slow, feed it slowly. A welder should focus on checking the molten puddle because the weld profile relies on both the filler metal feeding speed and the travel speed. From 5 to 10 millimeters ahead of the endpoint, chip by switching on/off the arc as the heat will be accumulated at the end. Aluminum has a low melting point. Control carefully to avoid the heat concentration on the base material. Horizontal corner welding. Start an arc at the starting point and check whether the material is melting or not by preheating the material. If the welding rod is placed in the state that the base material is not melted, it will not penetrate and will be rounded up on the base material. Feed the filler metal after checking base material is melting. Then, heat will transfer to the base material. The melting speed of filler metal will be increased as an approach to the end point from the start. Feed a small amount of filler metal at the end of the molten puddle to avoid large volume feeding. If too much filler metal fed, excessive bead convexity is formed. When electrode touches the base metal, base material gets a blackish oxidation. Horizontal fillet welding. Weld keeping the electrode work angle at 45 degrees and travel angle at 70 to 80 degrees. For corner joint, heat transfers easily, but for fillet joint, heat does not. Wait long enough until a molten puddle formed after starting arc at the starting part of the fillet. Feed the filler metal. When the molten puddle is filled up to the marked guide line from the center of the bottom and upper plates to the inside. At this time, Continue welding by feeding and pausing the filler metal repeatedly in front of the arc instead of feeding continuously. A welder should focus on checking the molten puddle because the weld profile relies on both the filler metal feeding speed and the travel speed. At the end point, keep the short arc and make 2 or 3 spot welds. Aluminum welding should be completed at once without fill pass and cap pass welding. The single pass shall form back bead as well. Check the welding quality. Check the welding quality of the aluminum structure visually when welding finished. Check if the welds are free from welding defects. Check if the weld bead width is uniform and regular and free from excessive face reinforcement. Check if the weld metal is completely free from surface porosity and undercut. Check if the fillet weld leg length is in accordance with the specifications and free from burn-through. Check if joints are free from linear misalignment and completely welded. Check if corner welds exhibit a full radius contour. Check if all back beads exhibit well on the butt and corner joints parts at the inside of the structure. Please check the points of the tasks you have done this time.
한번 체크해 보세요.
So far, we have learned about welding aluminum structures. Thank you for your hard work.
수고하셨습니다.